Hey, I'm Mr. Bohoric, and today I want to talk about scatter plots. So this is more so, I should probably call this scatter plot with slope and linear equations. But I want to talk about scatter plots. Scatter plots are basically, it's a collection of data. It's all represented by ordered pairs. And really, the whole point of a scatter plot is to try to see if two different variables are related somehow. So to try to see if two just random variables, it would seem like things that are not related, see if they have some kind of relationship. Maybe as one variable increases in quantity, the other one decreases, or maybe as one goes up, the other one goes up. So let's take a look at an example of this, and I'm going to make up a lot of data off the top of my head for this example. So we'll need a graph, and let's say I'm graphing, I'm trying to see if the number of hours spent studying, so number of hours studying, I'm trying to see if that somehow is related to uh, the test grade the next day. So I'm going to see if that's somehow related to. So each one of these data points I'm about to write represents a person. So let's say little Jimmy, he studies for 1 hour, and he doesn't do so hot. He gets a, I don't know, a 63. Okay, and then Jane, she studies for 9 hours, and I'm doing like crazy numbers here. So please just go ahead and bear with me with some of these numbers. So she studies for 9 hours and she gets a 97. Billy, I don't know, he studies for 5 hours and he gets a 75. Jethro studies for 3 hours and gets a 70. Let's see, what other colors can I use? Here we go. Phil studies for 10 hours and he makes a 99. Let's see. And how about let's do one more. Let's do one more. This will be a really simple scatter plot. Say, I don't know, somebody doesn't study at all. They get a 51. They just barely got half of them right. So let's go ahead and graph these data values on our graph. So we're going to need to label our graph. So 0, and let's say the x-axis is the number of hours studying, and I should label that, but, well, I could, I guess. The number of hours studying. And on the y-axis, that's going to be the test grade. All right, so let's label that real quick. So, excuse me, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And then obviously for the y-axis scale, I'm going to have to change up the scale a little bit. I'm probably going to go up by tens. So 10, 20, if you can actually see that, 30, 40, 50, 60, 70, 80, 90, at the very top, 100. So let's go ahead and graph these points. So I don't even remember who I said the first point was. So for 1 hour, they got a 63. So that's about right here, more or less. And then for 9 hours, there was a 97. So 9 hours and 97. That's like way up here. 5 hours was a 75. So 5 hours, 75. It's about right in the middle, right there. 3 hours was a 70. So 3 hours, 70, and that's a nice point to graph. 10 hours was a 99. So that person just killed it right there. If you can see that. And 0 hours was a 51. Right there on top of where I wrote 50. So you can see, here is my data, if you can actually see that. I've got a point, and I'll circle each one in red so you can see it. I've got a point here, 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 and on your paper you would not circle these in red. So just letting you know. Here, and here. And it's pretty obvious that my data is not linear. This does not form a nice, pretty straight line. Although you can kind of see how it does kind of slope upwards. If I were to draw what we would normally call a trend line, or a line of best fit is what some classes call it. Trend line, lines best fit, they're the same thing. So if I were to draw some like imaginary line that's going to try to go through as many of the points as I can, or at least get close to them. So I'll draw it as a dotted line. So it's going to at least get close to those points. So there's my trend line. And you can see that, you know, it does kind of follow a pattern a little bit. I bet if I had more data values, there'd probably be more points around this line. It'd probably be all over the place. So you can see that the points kind of follow this upward sloping pattern. So you see how I just said that? Upward sloping pattern. So that means there probably is some kind of relationship between these variables. So this would be called a positive correlation. And a positive correlation is just basically when you have a trend line with a positive slope. And the way to think about this is as one variable goes up, okay, variable 1 goes up, then variable 2, should be a V, variable 2 is also going up. And actually it's the same thing. So variable 1 goes down, then variable 2 has to do the same thing. So you kind of think of they both have to do the same thing if it's a positive correlation. And that makes sense here. As you spend more and more hours studying, hopefully your grade goes up and up and up and up. And the less and less you spend studying, your grade's going to go down, down, down. So that actually makes sense. This is a positive correlation. And we could actually write the equation of a line based on this. So I'm going to say y equals, okay, well, the slope is kind of tough, so I'll skip that and just move to the y-intercept, 51. And if I didn't have an exact y-intercept, because here I do have an exact intercept. Whoa, I don't know what just happened there. So here I do have an exact intercept. Let me scroll back up. And that exact intercept is 0.51. But if I didn't, I would just pick wherever it crosses the y-axis the best. So I would just kind of have to guess. And it looks like my slope, from the best of what I can tell when I drew my trend line, I think the slope is about a half. So I'm going, well, I shouldn't say a half. It's up 10, excuse me, and then over 2. So the slope should be about 5. I used a different scale, so it doesn't look like a half. So kind of up 10, over 2, up 10, over 2. So up 10 over 2, that should be 5. And let's just test that out real quick. So like what if I want to predict what would I make if I spent like, I don't know, 6 hours studying. Okay, so 6 hours studying. Well, I would plug in 6 for x, because x represents how many hours to study. Let's see, that's 30 plus 51. So if I spent 6 hours studying for what I guess is like probably the toughest test in the world, okay, that would be an 81. I can predict that I would make an 81. It doesn't mean I get an 81. Okay, it doesn't mean that's exactly what I'm going to get if I went in there and took the test. It just means that that's kind of a prediction. Using my trend line, I kind of can predict that I should be around that area if I spent 6 hours studying. And who knows, maybe I guessed a lot more right, and maybe my data would be an outlier, and I would get like a 20 or something. I just bombed it by accident. So that can happen. Okay, this isn't like set in stone or anything like that. It's just a prediction. Okay, it's kind of like, this might happen. So just to clear, that was a good example to start off with. But to clear it out, there's more than just positive correlations and stuff like that. And to save you some time from the video, I'm not going to spend another time graphing a huge example like this one, okay, because that took quite a while. So I'll erase some of this. I really need to figure out a better way to erase on this program. All right, so probably is an easier way. I just haven't had time to sit down and do it. All right, so negative correlation. So there are negative correlations as well, and this is basically like if variable 1 is going up, it's increasing, then variable 2 is going down. They do the exact opposite. If variable 1 goes down, then variable 2 goes up. So let's some things that I don't know that could relate to this. Maybe, so no offense to you MTV viewers out there, but honestly, I'm just not a fan. So I would say that the number of hours spent watching MTV, as that increases, then IQ would go down. So, no offense if you're an MTV watcher, but that's probably true. I'm just making that up. And I'm sure there's no studies to actually show that, but it's a pretty funny example if I might say so myself, so thank you very much. So, that would be a negative correlation. As one's going up, the other is going way, 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 way down. Now, there's also something called no correlation. And this is if, like, data is just not if they have no pattern at all. There is no pattern at all. It's not like variable 1 goes up, variable 2 goes down. It's just like when you graph the scatter plot of this, and I'll just draw a really quick graph, the data is just all over the place. You see, remember how like in our last example, it kind of like lined up? This would be like a no correlation if all the points were just everywhere. So there's no pattern, there's nothing going on here. So in this example, this would mean no correlation. And I guess an example like this in real life, if I say like the number of hours brushing my teeth, that does not correlate to how many shoes I own. Okay, those two are in no way related at all. So that would be like a no correlation. You may find that in, I don't know, scientific studies, people try to find correlations between things like this. And unless they have some really good data or it's just a solid experiment or something, they're usually probably not going to find anything. The number of hours spent brushing teeth, that doesn't really relate to how many shoes I own. That doesn't really even make sense. Hey, why does owning shoes have to do with brushing my teeth? It doesn't. So that being said, that would be a no correlation. All right, well, I'm Mr. Bohork, and that was all I have today for scatter plots.